All right, guys, welcome to our geometry review. Are you guys backwards? This is going to be interesting. Can you guys hear me out there? All right. What's going on, Luke? Here we go. All right, we're starting with our geometry. How do we flip the window here? Wait for it. Oh, man. All right. For some reason, we're going backwards. No donating money. All right. Here we go. So we're starting on part one. Hopefully you guys are following on your end. I got to figure out how to flip this around. Interesting. All right, start with number one. Is this backwards to you guys too? This is bugging me. But all right, we're starting with number one. We can see the image here. We're doing a rotation of these two shapes. So we're moving RST. We're going around this way. Remember, when we do a rotation, that is a key word here, right? This is a rigid motion. It means we're going to get a congruent shape, okay? So when we take a look at this one, like that, so it doesn't happen anymore. It's not flipped. Perfect. It looks flipped on my end. So as long as it's not on yours, you're good. All right. We want to start marking things that are corresponding. So we see A, B, C, R, S, T. So A, when we rotate it over, okay, R is going to go onto A, so that's going to be congruent. Okay, S is going to go on to B, so you can mark that down. And then T is going to rotate onto C, all right, as we rotate around. So just match up the stuff. Is A equal to R? Yes. Is A equal to S? No. CB is this side here. Is that going to be the same thing for TR? So I'm looking at the two angle marks, 2 and 3, and then 2 and 3, so that should be TS. All right, and then CA, 3 and 1 that I marked should be TR, and it's TS, so I know it's got to be choice 1. So use those angle markings when you go about doing your question here. Number 2, all right, in the diagram below, all right, everything's marked for us. We got 43, we got 152, we got parallel lines AB and DEF, and remember, you got parallel lines, we're looking for our favorite letter. Okay, look for that Z for those alternate interior angles. And then what other angles can you tell me the measure of, right? So if this is 152, okay, for you guys, we're just going to do that minus 180. So 180 minus 152 should be 28. All right, grab a new pen, will do. Can you see red? How about if we zoom in a little bit? All right. And then if this is 28, that angle up here is 28. If this is 43, this angle down here is 43. Those are alternate interior angles. And then we can combine the 28 and the 43 together to get 76. Okay. And then this is going to be 180 minus that. Okay. So this is going to be 104. Now we can go about and talking about these angles. So is angle D 28? No. Is angle A 43? No. Is angle ACD 71? No. BCE, right? What about this angle over here? Is that 109? If ACD, if this is 104, double checking the math here. 28, looks good to me. 43. 71. Oh, there's a problem. 71. Look at that, people. Okay. And then if that's 7, this is 109. So now that makes a little more sense. So is BCE going to equal 189? What about ACD equaling 71? And that would be true because these have to be supplementary. Okay. So we know these are out. And then we have to double check our math to make sure this is going there. All right. On to the next one, number 3, okay? Diagram below, we're parallel. Figure 1 and 2 are a reflection. 3 is the image after a reflection on line N, okay? So be careful when they say it's the image. Figure 2 is the image of figure 1. So this is my original. That's my OG, okay? Figure 2 is the image of that, so this is the first image, all right? And then figure 3 is the image of figure 2, so this is image 2, okay? Which one's the original? Which one's the first image and the second image? What translation would move 1 onto 3? So this would just be, remember, we're not rotating it, we're just sliding it over. That's an easy one. That should be a translation, okay? All right? Doesn't matter. They're here to learn, okay? Number 4, all right? In case you're joining us, we're on the June 2018 Geometry New York State Regents exam, all right? So going through, AI intersected C. We have these ones are drawn. We got 65, 115, 7.2 is labeled for the sides, and they want to know what the length of CB is for this question, all right? So as you're going through this one, okay, if this is 65 degrees, the angle right next door to this one, we're doing 115 minus that, right, to straight line, okay? That's why they're telling you we have straight lines here. So we're going to do 180 minus 115 to get 65. And now I know that these two lines are parallel, okay? So as soon as I know they're parallel and we have these vertical angles, we can tell us that these two triangles, all right? Algebra stream's not happening, buddy. Welcome to geometry, though, all right? So if the triangles are similar, then we know the sides are proportional. So if we're looking for the length of CB, we can call that X, and then we're going to match up our corresponding sides for proportion. So proportionally, we can go from small side to larger side in the triangle, or do corresponding sides. So we could say something like DC is to CB, right, equals, and then we're going to jump back to the smaller triangle again, as AC is to CF. If you wanted to stay inside the triangle, you could do something like DC over AC, and this time we're doing short to long, small to big, so we would do CB over CF. And regardless of how we set this up, as long as I'm cross-multiplying and getting the same amounts, okay, we're going to know that this is going to be all right. So all I'm going to do here now is basically just set up my proportion itself. So 7.2, okay, over X is equal to 9.6 over 21.6. And then we'll just cross multiply itself. Just make sure you're consistent. So it's small, okay, DC, all right, over X, CB, and then it's going to go 9.6 small over big again, okay? So we're going to cross multiply. So 7.2 times 21.6 is going to get us 155.52 is equal to 9.6x, and then we just divide out, all right? And we had an answer of 16.2. All right, remember, you can also do, just a quick review, if you got your calculator, okay, if you're on a calculator page, you can go menu, number, okay, which is choice 2, actually not number, algebra, and then numerical solve, okay? And you can type in the original equation, 7.2. So if you have an equation you're not sure about, or you want to double check your answer, okay, over X is equal to 9.6 over 21.6. And then remember, you got to do comma your variable, and it'll solve the equation for you. So you guys can double check it using nsolve in your calculator. Just another way to go about doing that. All right. Yeah, nice stickers. That's what happens when you have kids at home. They put stickers on everything. You guys are jealous. That's all right. Okay, number 5. So given a square, so we're drawing a square, we're going to label our letters going around in a circle. Okay, so R, S, T, and V, if you want to go around essentially the quadrant ways. And it says square is dilated by a scale factor of 3, all right, on a given center. What is the perimeter after the image after the dilation? So remember, the sides, perimeters, altitudes, those are all going to get multiplied by the same scale factor, okay? Once I do from sides, perimeters, okay, when I jump to areas, remember that's when it squares. So if this is a factor of 3, this becomes 3 squared, all right? So if RS is 9 to begin with, okay, when I make my larger square, let's draw a small square, okay, if this is 3, if this is 9, this becomes 27, and that means all the sides are 27. So the area, or perimeter, would just be 27 times 4, all right? 7 times 4 is 28, carry the 2s, 16, 18, how about 1? Oh, 8, 10, how about 108? All right, and there we go with that one. Okay, so just remember though, the ratios for sides, perimeters, altitudes is the same. The areas become squared when we do a dilation. All right, number 6. In hypotenuse AB has a length of 26. Decide what's the measure of angle B to the nearest degree. So just draw out your triangle. Be careful where the hypotenuse is. All right, it's AB with a length of C. We did this one in class the other day, by the way. 26, 17.6. Do you guys want to go through the part 1 together, or would you rather jump over to part 2, 3, 4? That's another question for you. I'll just keep rolling on this until we get a little more information from you guys. So what we're going to do is we're going to find our reference angle first. That's angle B. Okay, we're going to label, so opposite, adjacent, hypotenuse. For SOHCAHTOA, find your angle, locate your sides, okay, from based on the angle, and then remember your SOHCAHTOA. Okay, Oscar had a heap of apples, whatever you guys are doing for that. And we're going to pick our function. We have adjacent and hypotenuse, so we're going to pick cosine. So the cosine of my angle, that's B, is equal to the adjacent side, which is 17.6 over 26. This can't be over 1. So remember, if you try to do it over 1, you'll get an error. Okay, and then we're going to do the cosine inverse of both sides. This is kind of the arc cosine. You may have also heard that. If you're from Bulgaria, maybe. I don't know. We'll see. So calculator. All right. We're going over to the trig button. Trig button right over there by the 7. Okay. And make sure your calculator's on. You're going to have this thing pop up during the exam. All right. So cosine inverse. All right. 17.6. Come on now. Divided by 26, okay? And then same thing. Once again, you can also just do end solve. So if you forget, there's an option for you there. It does say round to the nearest degree. That would be 47.3, so 47 degrees. All right? And there's our answer, okay? If you tried to do the cosine inverse and your fraction is upside down, when you do 26 over 17.6, you will get an undefined message. You can't have cosine more than 1, okay, because that would essentially mean that this side is longer than that one if it's more than 1. So that's where the errors come up. The greenhouse question, rectangular prism with a cylinder top half. All right, they tell us some dimensions here. It's 12 feet high, 25 feet long, and the diameter there. They want to know the volume. Okay, remember in the back of your exam here, we have our reference sheet. We'll tear that out. All right. Okay, and remember the volume formulas are down there. It doesn't have surface area, so if there is a question that pops up, just remember it's the area of all the surfaces, so find the area of all the sides, add them together. All right. Quadratic formulas on there as well. Radian degrees is on there, okay? And that should be all we're pretty much using for ourselves. And then it's got conversions up top for us, okay? So we're on this question right here. So we're doing volume. So there's 2 shapes. There's a half cylinder. So that's 1/2 the area of the base times the height. So pi r squared h. And then we have the volume here of the rectangular prism. Yeah, we'll say P for prism. All right, so the volume of the prism, okay, is essentially going to be length times width times height. So the length here is 20, okay? We got 20 going this way, 12 going that way, and then 45 going all the way back. And then the volume of the half cylinder is 1/2 times pi. R, once again, is half of this length here. Okay, that's also the height, by the way, in other questions that may come up, which is 10. So 10 squared. And then the height of the prism would be, if we stood it up, would be this 45 over here. In terms of pi, just leave pi in your answer. So type all the numbers in, and then look at pi. This one says nearest cubic foot. So our answer, we're going to want to round here. So 20 times 12 times 45, we end up with 10,800. And then when we do 1/2 times pi, and I'm going to do it without for right now, just so we can see both. Okay, so this becomes 2,250 pi. This becomes 10,800, and then we're basically going to add those together. So if we go up, I can grab that number, plus, and here I can do control answer to grab that answer, times pi, and there's my final answer. So 17,868, since the number is a 5, we're going to round up to 9, okay? And there's our answer for that question. All right, number 8 in the value of the acute angle here. So remember, this is the one where in order to be doing sine, cosine, and tangent, I have to have a right triangle. Okay, so it's saying the sine of, and this is my angle, the sine of A, cosine of B, okay? In order for these to be equal, we're talking about A and B being these angles. That means that these have to be complementary. Okay, doesn't mean that they tell each other they have nice clothes on or shoes or something like that, right? But that they add to 90. So we want to take 2x plus 4 plus 46 and add it to 90 and solve. So we get 2x plus 50 is equal to 90. We'll move that 50 over to get 2x is equal to 40, and then x is going to equal 20. Now, another question. If you don't know what to do, you're going to bust out some NSolve. So menu, algebra, NSolve, we'll type in our equation. So sine of 2x plus 4 equals cosine of 46. We're going to do a little comma, tell it x, hit enter, and there's our answer. So if you forget, bust that out, okay? We did this one today. You guys remember this one, guys? Parallel lines. So as long as this line is parallel to this one, this is creating a side splitter here, and we have these two similar triangles that are formed, okay? Two similar triangles here. All right, so as long as they're similar, these base angles are going to be equal here, okay? And this is going to be a shared angle, and so we know that triangle DEF is going to be similar to AEB. I automatically know these two won't be able to work because I don't have any side lengths that are the same. And remember, for congruence, it's side, 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 angle, side, angle, side, angle, 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 side, or HL. All of these involve some sort of side length. So if you don't have a side, you can't do congruent, okay? All right, number 10, base of a pyramid is a rectangle, all right, with a width of 4.6 and a height of 9. So you want to draw yourself a rectangular pyramid here. Once again, if you're joining us, we're doing the June 2018 New York State exam. All right. So the width is 4.6. The length is 9 for the base. And the height of the pyramid is given is what we're trying to find. If you drop a line straight down like you're dropping a rope inside the pyramid, this gives you the height. The other height that we have here is called the slant height. That's the height of the triangle down the side. All right. So that's what we're doing here. So when we're doing volume, remember it's the area of the base, okay, times the height, and it's 1/3 of that. So 1/3 of the area of the base times the height. If it only has one base, you're doing 1/3. All right, the base is a rectangle, so it's 4.6 times 9, and we don't know what the height is yet, and we're going to take this number and plug it in for the volume. So 82.8, and then we're going to do 1/3. Okay, 1/3 of 9 is essentially 3, so 4.6 times 3 is 13.8. h, and then we'll divide that out by 13.8, and we'll have our answer. Also, there's only 3 answers, so you could just plug in until you match that volume. So if you forget what to do, you guys can go about doing this. And we should end up with a volume of 6, or a height of 6. All right? How you guys doing out there? Number 13, we got a parallelogram with diagonals given. All right, so remember, parallelogram, essentially the diagonals, there's some things we know about the parallelogram, right? We know the opposite sides are parallel. We also know that they're congruent. Okay, we know that the diagonals are going to bisect each other. Okay, we know that we got like one pair of sides going to parallel. The angles that are next to each other are going to add 180. The opposite angles are going to be equal. So which of this is suffice to say it's a rhombus? So there's 2 properties of a rhombus, okay, that we're going to, glad to hear, Lego. All right, the 2 properties of rhombus we're going to focus on here is that all the sides are equal, okay? And in order to do that in a parallelogram, all I have to do is get one set of sides that are next to each other. Consecutive sides congruent. So if you think about it, this is 40, okay? As soon as I show that this side is 40, it forces the other pair, these 2 pairs to be 40, and then they're all equal. The other option is that I'm going to get right angles in here. So these angles are going to be right angles, the diagonals are perpendicular, or the diagonals cut these in half, okay? So this angle here is going to get cut in half. And since it's a parallelogram, the other angle, BCD here, is also going to get cut in half. And these 4 angles here are going to be the same. The same is true for these sets of angles over here. All right? So which is going to make it a rhombus? BD bisects AC, not going to be enough because that's actually just for a parallelogram. Any parallelogram, that's true. All right? AB is parallel to DC, same thing. That's just for any parallelogram, so it's not enough. AC is congruent to BD. These are the diagonals. So this is actually true for a rectangle, to make it a rectangle. Technically, a square would have that too, but it's enough to make it a rectangle. And then AC perpendicular to BD would be the one we're looking for 90-degree angles. All right. Ms. is in the house. Number 14 here, directed line segment. So this is the question where if you have graph paper, remember, on the exam, okay, they will give you a sheet of graph paper, scrap graph paper, right here. You can fold it into fourths, okay, and make 8 graphs for yourself if you want. All right. No trading graph paper, though, not allowed. But we're going to cut this into a section of 2 to 3. So remember, essentially what we want is we want a line segment, okay? We want to find a point on the line segment so that there's 2 parts on this side of the line, okay, and 3 parts on this side. But all together, there's 5 total parts. So even though it says 2 to 3, I want to know what fraction of the line DF is going to represent. And it's going to represent the 2 parts over the 5 total parts. It's always the first number and then the sum of the 2 numbers. This is what we're using for this question here, okay? So 2/5, let's straighten this out a little bit here, all right? And then all I want to do is count the rise and the runs. So if I'm traveling from the point from D to E, I'm going from -4 to 1. This is the change in X. So that's a +5 to move that there from -4 to 1. And then from -2 to 8, I have to add 10. All right? So you can think of this as moving 5 units in this direction and then 8 units up. And instead of moving all 5, I want to move 2/5 of that. So for our change in X, okay, we're going to multiply the change in X, which is 5, times our fraction of 2/5. And that tells us that we're only actually moving over 2 units to the right instead of all 5. And then for the change in Y, we're going to take that change, which is 10, multiply it again times 2/5, which is going to give you 5. Nope, scratch that. 4, okay, 20 divided by 5, right, 10 divided by 5. And then what we're going to do is we're going to take these 2 changes and we're going to add them onto point D. So point D has coordinates of -4 and -2. And we're going to add 2 to the X, we're going to add 4 to the Y, and we end up with a point of -2, okay, 2, and this is going to be our answer. So that's choice 2. All right. So remember, fraction of the line we're using from the ratio, count your change in y, change your x, multiply times the fraction, and add it to the first point. If you got a graph, right, you're just going to graph those points. So, got a graph, okay. -4, -2, and then 1. I think I broke it. Remember, you're not allowed to actually add lines on yours. 1, 2, 3, 4, 5, 6. We'll go 7, and then 8. This would technically be a -1 on the exam, by the way, guys. All right. So if I'm counting the change in y and change in x here, okay, 1, 2, 3, 4, 5. I'm going over 2 of these units, and I'm stopping. And instead of going over all 8, I'm going up 2/5 of that, which is, we're going up 4. So I'm going over 2, up 4, and there's my point, okay? That is the point, -2, 2. All right, so that's how you use your graph. All right. Still rolling through here, guys. Let me know if you guys have a specific question on a topic while you're out there, too. Math related. Why is -1 for more graph line? Oh, so, for example, number 16, they're providing you the grid, okay? The scrap paper is not graded. You can't grade that. If you look at the top of the graph paper, wherever I just put it, it says it will not be graded. So it's for you to use on your own, but it's not actually going to be graded. Mind the glue stick. All right, so you can see at the top, this sheet will not be scored. All right, but if they give you this this graph, you're not allowed to go off of the graph. So if you needed to, say for instance, graph something that had more than 10, you'd have to change your scale and count by 2s or 3s or 4s. Or if it's a graph, maybe you're going to do a break and skip some numbers. That's essentially what's going to happen on this one. While we move on to number 15, okay, graph on the vertices below. What's the area? What's the area? So normally for this, I need a base and a height. The other thing we talked about doing this is we want to just basically box this thing in, okay? So we're going to draw our box around it. And by doing that, we're essentially going to get left with this rectangle and then these right triangles on the outside. So, oh, we got a little fight upstairs. Kids are getting loose. If we add lines to scrap paper, no, you do not lose points for scrap paper. That, like, literally, this paper doesn't make it in your exam. So you take the graph paper, this doesn't get counted at all. So if you add lines to the scrap paper, you're fine. However, if you add lines to any graphs on parts 2, 3, 4, actually. So it's just a question on part 2, 3, 4. If you were doing a graphing question, that's where you can't add lines. So for instance, number 32 has a graph on it. You have to stay on that grid, okay? You can't go off of it. So if mainly algebra more than geometry, but just in case. But off the graph paper for the scrap paper, no. That's all yours. I won't see it. Also, don't draw anything obscene because it will be seen by the proctors and you don't want to get in trouble. All right. So what we're going to do for this is find the area of the whole square and then subtract away the area of the triangles. So we can just count. The reason why we're doing it this way is I can't count the diagonal distance without doing the distance formula, but then I also don't know exactly where that altitude is going to go in here. So the easiest way to do is just draw a box around it. I get the area of the box and I can count the height and distances going this way. So if you count it up, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, looks like 11. Okay, we got 3 across this way. We got 9 this way. Should be 11 back down. It is. This is 7 and 4. And then we got, should be 12. 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. And we did. So I'm just going to do the area of the entire square itself, okay, which is just length times width. So 12 times 11. All right. 11 times 11 is 121 plus another 11. Should give me 130, 123. 132. So close. All right. We're also going to do the area of the triangle. So triangle 1, remember, is 1/2 base times height. So 1/2 11 times 3, which is going to come out to be 16.5. The area of triangle 2, okay, is 1/2 9 times 7. So 63 essentially divided by 2. All right. And then triangle 3, we have 1/2 12 times 4. Half of 12 is essentially 6, so 6 times 4 is 24. So we're going to add these three up, okay? So 16.5, 21.5, and 24. Gives us 72. And then we do 132 minus 72, and we got our answer, which should be 60. All right. Going on to the next one. That question's worth 2 points. A lot of work for that question. All the part 1s are worth 2 points. Part 2s are worth 2 points. Part 3s are worth 4, and part 6 is worth 6 points. Sorry, part 4 is worth 6 points. There's just 4 parts to the exam. 21. In the diagram below, we got their triangles, and it's drawn parallel. As soon as it's drawn parallel, this is a side splitter question. So immediately we know we're going to be getting parallel lines. We got sets of congruent angles, just like on the last question we talked about. So we know that we got 2 similar triangles, okay? All right. All right. Yeah, it is just 3 triangles. That's why the benefit to doing the box method, the right triangles are easy to do the area for, so it just makes the problem a little bit easier to keep track of. So in this case, we're talking about these 2 triangles. We're trying to find the length of QR, so we're going to call this entire side X. So if you notice, either we're doing a side splitter theorem where it's going to do top to bottom, or we're going to do something where it's the entire triangle, okay, the small triangle to the big triangle. Since we're talking about X, which represents this entire side, okay, we have to use small triangle to big triangle. So this side right here, QT, would essentially be X minus 5. If this is X and this is 5, that's the difference. And then this side, we need the whole thing, which you could call 7. Now, optionally, you could call this X, okay, and just do the ratio of the 2 sides, 5 over 2, X over 5, and then just remember to add 5 to your answer, okay? So in this case, we're going to do big triangle to small triangle, so 5 over 2 is the same as, and this one we're going to do X minus 5 over X, all right? So we're just doing top to bottom, actually top, don't do bottom, top to whole, so 5 to 7, okay, and then X minus 5 over X on the other side. So we cross multiply, get 5X is equal to 7X minus 35. We bring that 7X over, keep track of that negative sign, and then we divide out by -2, and we get X is equal to 17.5. All right? So if you treated this X, you would get 12.5. Notice that's an answer. Remember, you have to add 5 to it all the way to get to this. Okay. Number 22. The diagram below shows a circle with radii, measures of angle AOB, that's our central angle, is 120. That means this arc also has a measure of 120. It's degrees, it's not the length, okay? We're doing 6 inches, or a radius of 6 inches from here to here. So we want to know how many inches it would take to travel all the way around here. We want to know that length. Now remember, there's 2 formulas we talked about. One of them is in radians, okay, which is not this, all right? This is in degrees, so we're not going to use that formula. Our formula is the angle over 360 times the circumference, 2 pi r. Would it be 7 over 2? No, it would not be that last question. I'm going back. Going back. Okay. Where are we? Nope. We'll find it. We're getting there. I'll go back to it after this. It's right above us. What are we doing here? Okay. Remember, we did on this side, right, the top to the whole. Top to the whole. So on this side, we want to do top to the whole. All right. So that's why we're going back, not 7 over 2, right? If you want to flip it upside down, if we did, now you mentioned it's 7 over 2. Did I do over 5? Okay. The reason we're not using 2 is because it's not a side in one of the two triangles. It's the big triangle to the small triangle, if that makes sense. The bottom isn't part of a triangle, so we're going to stay away from that. So 7 over 5, okay? And then x over x minus 5. One of those things, okay? Or we could do 5 over 2, and then this side, qt, I'll call x over 5 this way. Those are the two things we're looking at there. So sorry to take it on a little detour. Hopefully that made a little bit of sense. 22 down below. Here's our formula for degrees. There's also another one that works, which is essentially the angle over 360, and you can actually set up a ratio like this is equal to the arc length over the circumference. And you can actually solve using that proportion. No problem. I'm glad it was neato for you. All right. Cool dancing, singing guy over there. All right. And then this is equal to the arc length. So if we know this is 120 over 360, this tells us how much of the circle we're using, which is just a third. So that means I just want a third of the circumference. Okay. So I'm taking a third of 12 pi, which is equal to the arc length. That's what AL stands for. And we get 4 pi. All right. Now, 4 pi is one of the options, but if we find our way back here, we see it's 1/3 of 12 pi. That ends up being this. And there's our answer. If it was in radians, okay, arc length in radians, remember, is that's usually S is equal to R times theta. So R is the radius times radians, okay? Radius times radians. If you're going to use this proportion we talked about over here, can you guys do that all right? Whoop, wrong way. Okay, you can actually do the same thing where it's theta over 2 pi is equal to the arc length over the circumference. So you can kind of just swap out 360 for 2 pi, kind of another way to do it. And actually, that's all we're doing when we do this formula too. If we put 2 pi here, the 2 pi's cancel, and we get angle times radius. So that's where that's coming from. All right, number 19. I realized we skipped 19. Sorry about that, guys. All right. Polygon rotated about its center. So anytime I rotate about the center, I want to figure out the degrees of rotation of symmetry. So if I rotate it around 1 time, or if I rotate this around 2 times to this point, okay, let's call it 1, 2, 3, 4, 5. If I rotate 1 to 3, or 1 to 4, or 1 to 5, or back around, how many degrees is it? So it's 360 degrees around the whole thing, and we're going to divide by the number of sides and the number of vertices. So 360 divided by 5 should give us a degree of 72. So it's 72 degrees here, 144 there. If I keep going around number 4, that's going to be 72 times 3, which is actually 216, okay, which is our answer. And we want to match up one of these to that degree of symmetry. So if this were an octagon instead, we would do the same thing, okay? I would do 360 divided by 8 to get 45, and then I would look for answers that are multiple of 45, 45, 90, 135, 180, 225, 270, and keep going around, okay? And that's what we're looking for. Equation of circle O shown in the graph. Okay, 2 things. Number 1, all right? We can use our calculator to answer this question, if you remember how to do this. Now, we can identify the center and radius, okay? So the center is 1, 2, 3, 4, 5, 2, and the radius, which is going to count straight across, is 4. So if we were writing our equation normally, okay, it's going to be x minus h quantity squared plus y minus k quantity squared equals r squared. All right? Line it over. Okay? So when we plug in our center point, remember to change the sign. So it's x, and this becomes a minus 5. If this were negative, this would be plus. Okay? Plus y minus 2 squared, once again negative, this becomes plus, is equal to 4 squared, which is essentially just 16. So when you complete the square, notice how all these are the same thing. So we essentially want to do b over 2 squared, b over 2 squared, to complete the square. Okay? The b term is the term, the linear term with the x on it. All right? So that's the 4 and the negative 10, or the 10. And if I do 10 over 2 squared, I'm essentially going to get 5 squared, or 25. And if I do 4 over 2 squared, I'm going to get 2 squared and then 4. So I know that I'm going to add 25 and 4 to these numbers, and I know that I want this to equal 16 when I'm done. Okay? So that's kind of the way that I could go about doing this. So this is going to turn into 4, right? And I need it to be 16, so that's not going to work. This one, though, is going to turn into 16. All right? And then I would know that this is going to be x minus 5 squared, because this is negative. This sign's going to be negative, and this is going to be y minus 2 squared. So that's how I could figure out the answer based off the equation. The other way, easier way, to be honest with you, is to take your calculator, go to the graph page, and then remember we're going to press menu and then 333. Okay? That was on there from earlier. Let's try that again. No, we don't want to save. Graphing page, menu, 3, 3. What do you keep doing that for? You know what? I think the problem is, is my press to test settings are different than the ones yours are going to be in. But when you do 333, all right, and actually we can do this a different way too. If we press tab, okay, let me do a document here. No, I don't want to save. I want to go to a graph. All right, I'm going to delete this and I'm going to graph a relation. So if it'll let me do that, and I'm going to graph this. So we're just going to do x squared, okay, minus 10x plus y squared minus 4y equals negative 13. This one won't do it, but if we were to do that, maybe this is why. Yeah. If you type it in normally when you delete it and graph it as a relation, it will also graph it. All we're basically doing then is looking for the equation that matches this. All right. So I'll go over that in class again tomorrow for you guys. So there's those two. We got 2 more left here in part 1. Hopping into part 2. Thanks for sticking with me, guys, for so long. Number 22, altitude is drawn in right triangle. So anytime we see altitude drawn to the hypotenuse, that's our chopped out right triangle. All right. So we're drawing our chopper of a triangle. All right. Where we have a right angle up here, and we're dropping that altitude down. And what we're doing is we're creating 3 similar right triangles. All right. There's a couple different ways to teach this, but essentially what we're doing is we're going to draw out 3 triangles that look the same. Okay. So there's one. We're going to draw a little smaller version of this, so that this represents this triangle, and then we're going to draw a little mini-me for this guy. All right. So it says CD is the altitude to hypotenuse EF, and it's in right triangle ECF. So I know that this is here. We got C and D. We got so E, C. No, D's here. Okay. It says EF is 24, EC is 10. E, CF, right? No, we're drawing it wrong again. CF. CD is that way. There we go. So it says if EC is 10, and EF, which is this guy, is 24. So that's our hypotenuse. Okay. What's the length of ED, which is x? Okay. So if this is x, that means this is 24 minus x. And then what we're going to try to do is label everything we can here. Okay. So in this little itty bitty small triangle off to the right, you guys see the little small triangle off to the right. Okay. I have a hypotenuse of 10, which if this is my right angle, that's why we're drawing them all the same. Okay. This is 10. And the short leg, this is the shorter version of that. So this is the short leg, which is x. All right. In the big triangle over here, okay. Now the only thing I have is the long leg in this triangle, which is 24 minus x. I don't have enough here. And in the really big triangle, I have a short leg of 10, and I have a hypotenuse of 24. And all I'm looking at is for two sides in the same position, which I have, and then I can go ahead and create a proportion and solve. So I can do 24 over 10 is going to equal 10 over x. And then we just cross multiply. 24x is equal to 100. And we divide by 24, and we should get our answer. And it should be right around 4.2. Okay? All right. Make sure you hit Control-Enter if you're using your calculator so it doesn't give you the fraction back. And then we're doing the last question. This was the question that I would pull a graph out for. So if you have your graph paper or even a question that you did earlier that has a graph on it, you could even use that. All right. We didn't do, why did you guys tell me we skipped the page in 17? All right. It's my fault, by the way, guys. We'll come back. Let's finish up 24. We'll go back to it. Okay. I just took this thing apart and I've been jumping around here. All right. So if we have a graph, whether or not we do, we have an equation, and it says that we're doing a dilation, and it's centered at the point 0, 6. So there's two options here. Number one, the center is on the line, and option 2, the center is off the line. Okay? If it's on the line stays the same. Doesn't change. So notice, the point is the point 0, 6. 1, 2, 3, 4, 5, 6. Look at that. Look at that graph. You can't even see it. It's so good. All right. My line is y equals 3x plus 6. The y-intercept is 6. It's also right there, and it's got a slope of -3. So -3 over 1, -3 over 1. Not that guy. That guy. All right. My line looks like this. It goes right through the center. So that's the case. It stays right where it is. So the answer is actually just choice 2. If it were to change, I want to double the distance. So for instance, if it was the point, if this was the center was at the origin, I would double this. So if this was the y-intercept of 6, it would double to 12. And it would stay parallel, so the slope would stay the same. So it would be that guy. Okay? You should never choose one with a different slope. The lines are always parallel. All right? And we're going to go back to number 17 on this one. Number 17. All right. Nope, did not skip a page on purpose. All right. No worries, guys. We're going to get them all here. 17. So we have the chords drawn in. So remember, there's 4 types of angles. There's central angles. Central, remember, is the same. So whatever the measure of the central angle is that's drawn, okay, this measure, whatever it is, if it's 40, is the same as the arc, okay? There's also inscribed. Remember, inscribed literally means to draw a circle around the vertices. So if we have an inscribed angle, okay, something looks like this, all right, and this is half of the arc. So this angle would be 20 degrees, all right? So it's half the arc. We have angles that are drawn inside, which is the case here. This is the average of the arc, all right? And we have angles drawn outside, which is essentially just half the difference. So outside, remember, is different, all right, and we subtract. So we're doing the average. That's it. So these two angles, okay, the line segments are cutting through and creating these two arcs. So we're doing the average of those two arcs. So we're doing 72 plus x divided by 2, all right? is going to equal 58. So I'm going to multiply both sides by 2. If you multiply both sides by 2, cross out the 2's, people. This does not double, or just cross multiply. Okay? 72 plus x is equal to 58. So 58 times 2 is 116. And then I just subtract 72 away. So how about 44? All right? By the way, I'm not blaming you guys. My mistake for skipping this. 18. The medians are drawn, which is always going to be true. So if the medians, remember the word metroid, medians, metroid, all right? So the medians and the centroid, make the metroid, okay? We talked about this one before, the altitudes. Think of the phrase AO, make the orthocenter, okay? We have peanut butter and cheese, PBC. Perpendicular bisectors, make the circumcenter. All right? And then our last one after metroid, PBC, was the aid in. The angle bisectors form the in-center. Guys, just come up with some easy way to remember these things, okay? Some other mnemonic device you guys want to use. With the centroid, these are the medians. So these segments are all going to cut in half. That's what it means to be a median, that you're connecting to the midpoint on the opposite side. And also that this piece, okay, from S to M, is exactly twice as big as MC, okay? So that means that MC, right, is 1/3 of the whole segment. So is 3 times MC equal to SC? Yes, it is, okay? Is MC equal to 1/3 of SM? No, it's equal to half, right? This is half, not 1/3. Is RM equal to 2 times MC? No, it's equal to 2 times ML. And is SM equal to KM? And no, this is not, we don't know this, right? We're not sure. Because we don't know if it's equilateral or not. That would be the only time that's going to happen. So we're going with choice 1. That's option 16, people. Okay? When we rotate this thing around, whenever you rotate a shape, we want to figure out which side is staying the same. All right? So if we rotate it around BC, which is this side here, we're going to reflect over that line. So this triangle is going to reflect over that line. So if this is 1, 2, 3, 4, 5 units down, it's going to go 1, 2, 3, 4, 5 units up. Okay? This is our reflection. And then we want to trace the path that the vertices are going to take around. And you can see we get this cone that gets formed here. Okay? So if this was 5, now this whole side is 10. This is 3. And so we see we're going to get this shape as opposed to these. This guy would be if we drew it this way and we rotated it this way. Then we'll get this shape. We'll get this shape. See? For the rotation, for that one. Okay? Going around that way. But instead we're going to get this drawn up shape. So just reflect, okay, the figure over. So if it's a rectangle, it's going to reflect over the other side. And then we're going to trace the shape, the path of the vertices, okay? Trace the path of the vertices. And this is going to become a cylinder. Really, we're looking for cylinders, looking for cones. If it's a cone that's not a right triangle like this, if it's something else, okay, and I reflect it, I end up getting 2 cones back, okay, one on the top, one on the bottom. So that's the only other kind of wrinkle that popped in there. All right, getting into some part 2s. Part 2s. 25. Triangle ABC is the image. After translation, 2 units up and 3 units, 2 units right, 3 units up. Is it congruent? And explain why. We just want to say yes, it's congruent. Remember, the only transformation that's not going to be congruent is a translation. All we have to mention something here is the rigid motion, okay? Or we can just mention the fact that translations don't change the length of the sides. Or angle measures for that matter, okay? So the triangles will be congruent. So triangle ABC is congruent to triangle A prime, B prime, C prime, and essentially this is by side, side, side. All right? Welcome, Mr. James stuff. All right? That's all right. We're just on time for part 2, 3, 4. No worries. Okay? So this is what's going on with this one. So we're mentioning the side. Rigid motions is another one you want to mention, that it's going to keep the sides congruent. Try to throw a congruency theorem in there when you can. Oh, we're going to get there. But right now we're here. Okay, triangle ABC is draft on the axis below at the dilation scale factor of 2 from point D. So all we're going to do, scale factor of 2, is we're going to double the distance. Okay? Use the slope for this. We're going to double that distance. So to get from D to B, we're always traveling from the center out. I have to go up 3 and over 1. I'm going to go up 3 and over 1 again. And this is where B prime is going to go. All right? For C, we're going to go over 3, down 3, over 3, down 3 and more. And boom, that's where C prime is going to go. And then for A, we're going to go over 2, down 4, over 2, down 4. Okay? And there's A prime. If we were somewhere where, if it was centered at the origin, we would just multiply by 2, all right? So no worries there. And then all we're going to do here is draw ourselves a straight line. So on the exam, you will have a straight edge. So you'll have a compass and straight edge to use here, all right? And then gotta get resourceful. Use your bus pass for now. There you go. It says graph and label. If you don't have the primes or they're in the wrong spots, that's a -1. Okay? Be careful it doesn't say state the coordinates too, because if it says state the coordinates, make sure you say A prime, right? Is -4, -3. Put those points down for yourself. 27. Describe a sequence of transformations. So give me the transformations and give me an order. Since it's on a graph, we can just talk about we're moving this to this. Also be careful. See how the order of the letters is, okay? We have to end up with B on top of G, all right? And I on top of O. So if you just said I'm going to translate this thing by going here and here, you're going to lose half credit. B is not supposed to go on L, it's supposed to go on G, okay? So I have to do a reflection first, and then I got to translate it up. So if I reflect this over the y-axis, 1, 2, 3, 4, 1, 2, 3, 4, okay? This is 2 units away, it goes 2 units on the other side. That's another 4, and I is down at the bottom. This is where this is going to move, okay? So now there's K prime, E prime, D prime, and I prime. So we want K to go on top of, oh, I really did that wrong. Labeled wrong, K's over there, B's over there. All right. So now B will go on top of G when we translate up, okay? So the first thing we want to do, so first, reflect. Make sure you tell me what you're reflecting, okay? B-I-K-E over the y-axis, over and y on the same time, okay? Then, what do we want to do? We want to translate up 1, 2, 3, 4, 5 units, okay? All right, so 1, 2, 3, 4, 5, 5 units up. So reflect over, translate 5 units up, and we're good to go. All right, please be careful. I can't tell you how many people lost credit on this question because they just did a translation, shifted it up, but B went on top of L instead of going on top of G. All right, 28. Oh, look at this. We got ourselves a segment question. If this were an angle, this is outside, so it'd be bigger minus smaller divided by 2. However, it's a segment question. So remember, if I have secants drawn, it's going to be the whole secant times the outside piece for both, okay? So the whole times the outside. All right, so RS is 6, ST is 4, the whole secant is this whole length, which is 10. If RP, which is this side right here, is the whole secant is 15, RQ we're going to call X. So we're just going to do whole 10 times the outside piece, which is 6, is equal to the whole, which is 15 times X. And then we're just going to solve. This is 60 equals 15X, and that means X is equal to 40. 4. get out of town 40. All right? That's it. Any questions on that one? You guys all right with that? Make sense? You guys still awake out there? Appreciate you guys sticking with me here. Ooh, look at this one. I even thought ahead, guys. Wow, easy. All right, I hope it's easy. I even remembered to bring a compass home, guys. All right, so we want to construct a median to side AC. So the median, remember, connects at the midpoint across the way. So if we said AC, we want to draw in the side that what cuts that in half. So what's going to cut AC in half, okay? So essentially, that's a fancy word, guys, for the football. All right, we're doing the football construction. We're going to do the perpendicular bisector. That's it. All right, so median to side AC is going to be the perpendicular bisector. Now, what we have to do is once we find the perpendicular bisector, we have to connect B to make the median. Okay, the median is what's finding the middle. So because it's to side AC, we're going to do the perpendicular bisector of AC. Take my compass, open up more than halfway, just anywhere more than halfway, and then we're going to make a circle around C. Really just want an arc above and below. A circle around A. Can't see a thing. Arc above and below. All right, and then we're just going to connect to draw in to find the midpoint. Remember, you have to show construction marks. Construction marks are essentially your compass marks here, okay? So there's our perpendicular bisector, which means this is the midpoint, and now I have to connect that midpoint back to B. All right? So this is our median. All right? Midpoint, median. Oh, we got to fight up there. We did an expression today in class 2. Look at that. Remember? We used Pythagorean theorem. 5 squared plus 12 squared is equal to 13 squared. So we know that this is 12 and this is 13. So if the two triangles are congruent, are they also similar? So are they both correct? Yes, they're both correct. Okay. All right. The triangles are congruent by side, side, side. And congruent triangles are also similar. You could also mention something about, we say similar, not only is it congruent, it's also the sides are going to be proportional, so you could also explain it that way too. 31, Randy's basketball is in the shape of a sphere. Maximum circumference of 25.9 inches. Determine and state the volume of the basketball. So we're assuming it's filled up all the way, okay? So if the circumference is given, remember the formula is on the sheet here, okay? Circle, circumference, 2 pi r, all right? And the volume formula we're using for the sphere here is 4/3 pi r cubed. So we need r first. The volume is 4/3 pi r cubed. We need r. So C is 2 pi r. This is going to be 29.5, all right, is equal to 2 pi r. So I'm going to divide by 2 pi. Now I'm going to get some crazy number in a minute. So what I'm going to do is I don't want to use pi in the answer here, guys. If I try to do 29.5 divided by, now this is your warning. If you do 2 pi this way, the calculator is going to kick the pi out. So you're actually multiplying by pi after you divide by 2. All right. What we want to do really is make sure that this pi goes to the bottom here. So when I do my division, divided by 2, we want to use parentheses around the 2 pi like this. All right. Now I don't want to carry this number around. So what I'm going to actually do is do 29.5 divided by 2, which is 14.75, and leave the pi underneath. And I'm going to call this my radius. Okay. This is easier to write than this crazy thing. So now when I come over here, I'm going to do volume equals 4/3 pi times that number, 14.75 over pi cubed. If I didn't do that, I would just fill in this whole number. Just write the whole number right there. Okay? Now I'm going to take my calculator. I'm going to do 4/3, and we're going to kind of cheat here. We're going to do pi. Now it says cubic inch, nearest cubic inch, so I know I'm going to use pi in the calculator. I'm not going to retype this fraction we just talked about. I'm going to go grab that number, okay? And then we're going to do to the third power. And if you want to make sure that this is like it's going to multiply, you can go ahead and put a parentheses around it, okay? So we do caret and then the 3, and there we go. So nearest cubic inch, we're rounding, so it should be 434. Now, we don't have to technically label cubic inches because it's implied in the question when it says that. But I would put it down for yourself just in case. Don't label it with something else like centimeters, because then we're going to have to take off. And don't put squared. That's another one. All right. Part 3, a little bit tougher. Okay, 4 pointers here. So triangle was given with coordinates. So A is -1, -1. So I'm just going to go ahead and graph it on here. -1, -1. There's A. B is 4, 0. And C is the point 0, 4. Okay, before you go anywhere else, go back and double check that you've graphed them correctly. -1, -1, 4, 0, 0, 4. Okay. All right, we want to prove this is isosceles and not equilateral. So what we're going to need for isosceles is 2 sides congruent, equilateral is 3. So our options are either use the distance formula, okay? Remember, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then we're going to just plug in. So if I know if I'm using this guy, okay, if we want to do the distance of AB, we're going to treat B as the 2 and A as the 1. So it's the square root of 4 minus -1 squared plus, and then it's 0 minus 1 squared. So remember, the double negative creates a positive. So 5 squared plus 1 squared. And all I have to do is show that these radicals are the same. As long as I get radical 26 everywhere, we're good. Now your other option, instead of the distance formula, is just to draw in, okay, your rise over run lines. All right, rise over run, and label. So this is 1, this is 5, okay, there's 1, 2, 3, 4, 5, and there's 1, and then this guy is 1, 2, 3, 4, and 4, and then we're just going to do our Pythagorean theorems. All right, so 5 squared plus 1 squared is 26, and this is the square root of 26, all right? And then we're going to do 4 squared plus 4 squared is equal to c squared, so 16 plus 16 is 32. All right, and that's all I would have to do for those two distances. What I would then go do back is go back and label square root of 26, square root of 26, square root of 32, and then I'm guaranteeing my grader then is going to see this, okay? If we keep doing the distance formula, we can keep going, okay? So square root, so we're going to go 2, so we got 0. We're doing AC, so 0 minus -1, that's our 1 squared, plus 4 minus -1, there's our 5 squared, and the distance is going to equal the square root of 26. And then what I would do is, remember how we labeled that AB? I would want to call this AC, so I have those for myself. And then the distance of BC, okay, is 0 minus 4 squared plus 4 minus 0 squared. And so this is where we're going to come up with the 16 plus 16 is the square root of 32. Now we still need a concluding statement. So we would want to say something about AB is congruent to AC because the distances are equal. And we can say AB is not congruent, okay, to BC. The distances are not equal. All right, and then we would just say ABC, triangle ABC, is isosceles. All right, okay. Since 2 sides are congruent, remember distances are the same, equal, and let's third side is not. All right. 33. Oh, look at that question. 33. Ooh, this is a nice one. The map of the campground is shown below. Campsite C, first aid station F, supply station S lie along the path. We haven't done this question yet. You guys should be excited. Are you guys getting thrown out there? All right. The length of path FS is 400 feet. The angle formed by path TF to path FS is 72 degrees. That's this guy. And the other one is 55. This is kind of like the question we did in class with the boat that moved, if you remember that one. Determine instead the nearest foot the distance from the campsite to the tower. So we want to get the length of this side right here. All right. So one of the problems we have is that we have two separate right triangles going on. All right. So in order to deal with this, let's highlight them both here for ourselves. We have this guy from the supply station to the campsite to the tower, TSC. All right. Right. And I'm looking for this, and I know that this is 55 degrees. Does that make sense to you guys? All right. The other guy is the smaller one, right? And this is from the first aid station, the supply station to the tower. So we know this is 400, and this is essentially 72 degrees. Now the thing to remember is that this guy is technically inside of this one, right? We got it here. Okay. Tuned in. Welcome, welcome. All right. So this side is being shared, and this is a right triangle. So remember, we're going to use some SOHCAHTOA stuff here. Pythagorean theorem, all sides. SOHCAHTOA when it's not. So if we can figure out the length of this side, we'll call this y. Why not? Then we'll be able to use some SOHCAHTOA in the really big triangle, the red triangle. So we need to use SOHCAHTOA to get this, and then once we have this, we can focus in on this triangle and do SOHCAHTOA to get this guy. All right. So starting with the small triangle, there's our degree 72. This is opposite. This is adjacent. Here's my hypotenuse. Okay. So remember, SOHCAHTOA. And we're going to pick the opposite adjacent. We're going to pick TOA. So the tangent of my angle is equal to the opposite leg over the adjacent leg. So the tangent of 72 is equal to y over 400. And then we're going to cross multiply. Remember, when you're looking for a side, you cross multiply. Okay? So 400 times the tangent of 72 is equal to y. And then we're going to bust out. Now remember, it says nearest foot. No rounding, people, until we get all the way done. Okay? So we get this guy. You see it? Right there. So y is equal to 1,231.07341487. Crazy number. That's what we're using for this, okay? So in the really big triangle we got here, let's redraw that one so you can see it, okay? Remember, bring your colored pens. We got 55. We got this side. Y, that's this thing, okay? And we're trying to find x. So once again, we're going to bust out some SOHCAHTOA. So y is the opposite side. X is my hypotenuse. So this time I'm using the SO, okay? So the sine of 55 is equal to the opposite leg, which is y, which is this thing. 1,231.07341487. Yeah, over x. And then we're going to cross multiply. X times the sine of 55 is equal to, how about we just call that y for a second? All right. You can actually use that variable since you've defined it to represent this. So you could put y in there. But we're having fun writing big numbers, man. 0.7341487. And then we divide that by the sine of 55. Okay? And so x, our length here, can you do the ... I would say just write out the whole number. I mean, you've already committed the 4 here. Just keep going. Or you can actually leave it as 400 tangent 72. So if we didn't want to write this, we could write 400 tangent 72. That'd be easier for you. And this is actually the most exact answer, so it's even better to write and then carry that through. Okay, so x is equal to, now we have our number in here already. Okay, so we're just going to do that guy divided by, and then tangent, nope, sine 55, and there's our answer. So nearest foot is 1,502.8, so we're going to go 1,503. Oh, there we go. That is really sloppy. Who told me to get a new pen earlier? You were right. All right. And then feet. Remember, we don't actually have to write down the feet because it says foot in the question, but remember, get in the habit of it. All right. How do you do? Did you guys try this one? We good? Do you need more time? Do we need to take a little break? You guys good? We're almost done. 34, we did this one. Do you guys remember this one? Shay, kickboxing. Models are different. All right. We have an unfilled base that's 270 pounds. All right. And the cylindrical base is 18 inches tall with a diameter of 20 inches, and it's dry sand. The base weighs 95.46 pounds per cubic foot. Ooh. Q on that. Q on this. We got a problem. All right. So it's got feet in it, and it's got inches. Okay. We're going to back out a little bit here. So I want to make sure I convert everything into feet because it's cubic feet. I have to do volume, okay, in feet for this. So what I'm going to do is basically divide these numbers by 12. So 20 divided by 12 comes out to be 5/3. So this is 5/3 of a foot. And 18 divided by 12 should be 1.5, yeah, is 1.5 feet. So we're going to use those numbers now instead. Convert them right away, people, okay? So we want to do the total weight and when it's filled to 85% of the capacity. So step 1 is to find the volume. Step 2 is to multiply the volume times 0.85. Step 3 is to figure out the weight. We're going to multiply that number, this 0.85D times 95.46. And step 4, we have to add on the 270 pounds we had originally to that guy. Okay, you can't see any of that. See it? We got to do that stuff. All right. Sound good? Let's do it. We're going to work up here so we have some room. So the volume of a cylinder is pi r squared h. So the volume, we'll do it in terms of pi until we need to round. All right. Our radius is actually half of this, so it's only 10 inches. All right. So 10 divided by 12 is 5/6. Look at that. So 5/6 squared times our height, which we know is 1.5 feet. 5/6. Any chance that you are a nice number? You are not. 0.83 repeating. All right. So when we multiply that number squared times 1.5, we get not fun stuff. So 5/6 squared times 1.5 gives us that guy. Yeesh. Right? Let's see if we can do a fraction. Menu, number, convert to fraction. 2. We get 25/24. So the volume is 25/24 pi. All right? And what we're going to do is we're going to take that volume and multiply it by 0.85. So 25/24 pi times 0.85 is equal to, so we're going to do that guy times pi, okay, times 0.85, and we're going to get 2.78161418, so close, 9537. Oh, good times right there, right? And this is cubic feet, so this is feet cubed. All right. What we're going to do next is do, remember, that times this 95.46 pounds. Okay. So we're going to multiply this times 95.46 pounds, and this will be pounds per cubic foot. All right. And here we go. So times 95.46. Every time I get 1 pound, or 1 cubic foot, I get 95.46 pounds. So we just multiply, and we get 265.53330501,568 pounds. All right. Now remember, this is the weight of this with the sand in it, with 65% of the way full. 5, 3, 3, 0, 1. You could round at this point. And what I have to do is I have to add on that original 270 pounds. Okay? And I get 535.533, right? And I'm rounding it to the nearest pound. So I'm looking at that 5 and saying, oh yeah, 536 pounds, people. All right? That's what we're looking at here. All right? Just checking one thing real quick. That is the correct answer, by the way. What's up? All right. Like it better be you teach this thing. So that's 34, and now we're going to do 35. So give it a parallelogram. This is a 6-pointer. It's going to be a beast, so be aware. We want to show that BEDF is a rectangle. So what we're basically going to need to get is either diagonals congruent, which is going to be very tough. They don't even drawn in. Or we're going to want to show that we have all these 90-degree angles. That's going to be our goal. All right. Get it to be a parallelogram with 90-degree angles. So let's start it off. You know what we're doing first. Statements and reasons, people. We're filling in. So we got parallelogram A, B, C, D. We got BF perpendicular to AFD. And we got DE perpendicular to BEC. So there's my given. All right. Keywords. We got parallelogram and we got perpendicular. So perpendicular lines, remember, form 90-degree angles. So we're going to go ahead and say that angle AFB is equal to 90, and angle DEC is equal to 90. And that's going to be the fact that these are perpendicular lines. So remember, perpendicular lines form 90-degree angles. All right. And we want to get the angles next door to these two to be perpendicular. So what we're going to try to do is a couple of things here. Now, kids are yelling upstairs. Now, because parallelogram ABCD is given, we also have these Z's going on here. Okay? You can see the Z's. So one way to get this angle and this angle to be equal to 90 is to use alternate interior angles. All right? So what we want to do first, by the way, this was 1, that's 2, here's 3, is we want to say that BEC is parallel to AFD. You can say BC and AD if you want. I'm just including the other points there. And this is because in a parallelogram, remember, don't abbreviate. Okay. Opposite sides are parallel. All right. And so now that they're parallel, I can use my alternate interior angles. So we're going to do angle EBF is congruent to angle BFA. And we have on the other side angle CED is congruent to angle, and we got EDA or EDF. It's up to you. We'll go F. All right. And then when the lines are parallel, right? The alternate interior angles that are congruent. What we can also do here is, last question. It's the last question, 35. This is it. All right. We can do the two cut by a transversal, all interior angles are congruent. That's the other way to write it up. So now I know that these guys are also 90 degrees. All right. And that's essentially just with substitution. So we have that. Now we need to get these two next door. Okay. There's another thing we can do with parallel lines, if you guys remember, which is if this is 90, okay, this guy has to be 90 because they're same side interior, they're supplementary. Or we can use the fact that these are making a straight line. So if this angle is 90, the other supplementary angle on the same side on the same line there is going to be 90 degrees as well. So let's do it. So we're going to say angle B. Well, first of all, let's get the 90 in there. Angle BF. We said BFA, right? Yeah. So EBF equals 90. All right. And angle, and we got this guy, BED. What did we say before? CED and ED, yeah, EDF. All right. And that would just be substitution. Or transitive. We're just substituting in the 90 from here, right, for this guy. And we're getting this. And we're substituting the 90 here, okay, to get this. All right. So then the other thing we want to do now is get this angle to be 90 degrees. Okay. So if this is 90, the angle next door has to be 90. Basically, they're supplementary angles on a straight line. So you can say it that way. You can also do the fact that 180 minus 90 is 90. So it's kind of how you want to explain it here. I can pull up some of the papers in class tomorrow and show you guys some of the things they said. Some of the other students that this had in front of you guys. But so we're going to say that angle, and we're going to use same side interior. I like that one. So we're going to do angle BFD. BFD is equal to 90, and angle BED is equal to 90. All right. And the reason for it is when lines are parallel, the same side interior angles are supplementary. So that's why if this is 90, this has to be 90. They had 180. Same thing if you wanted to switch this out and you wanted to say something like angles on a straight line are supplementary. So if one is 90, the other's 90. Anything like that would be okay. And then we have enough. So now we're going to say BEDF is a rectangle and a quadrilateral with 4 90-degree angles. No, because all 4 of the angles are equal to 90, so you don't have to do step 5. No, we don't. We're basically just substituting step 5 in there. I just want to be clear that it's equal to 90, that this is also equal to 90. So I know what you're saying there. All 4 angles are congruent, so they're equal to 90. I would want to definitely just make sure you state that statement in there. Just don't leave up to the grader to infer that that's what you're talking about. With 4 90-degree angles is a rectangle. All right. You could also do the fact that these lines are now going to be parallel, okay, and then do it's a parallelogram with a right angle. That's up to you. But there is your proof. All right, guys, that's an hour and a half. I am done with math for today. I hope you guys got a lot out of this. We may be able to do another one of these heading in. Wasn't able to come back from this one. What exam are we doing? We are doing the June 2018 exam. June 2018. June 2018. If you check your remind, I sent you a link to the exam. This video will be up there. You take the algebra exam next week. All right. Do me a favor. go to this website. You got to have access to Microsoft OneNote, but it's bit.ly.com/. Let me look it up real quick. Actually, if you check my YouTube channel, over on YouTube, so YouTube Mr. Zazowski, click in the algebra folder, videos, and there's review in there. There's topical review from day one all the way on. You can go there and take a look at those videos. There's also, let me see if I can find it for you. Pardon me while I search here. All right, this guy. Lego, this guy. Head there, okay? He's got videos on every exam with solutions. You guys can go there too and just go to the geometry exams. You're welcome. And let me get you the link to my folder here. All right, go there. If you can get access to it, you need a OneDrive account, Google, or Microsoft. So if you have something from school, if you go to the Buffalo schools, your 900 number will get you access to it. So your 900 number will get you in, and then you'll be able to get to the worksheets, the videos that goes along with Regents book from jmap.com. Anything else, guys? Other than that, I will see you all tomorrow. You can check the video. I think it'll save, and then feel free to check it out and go through it. All right, guys. That's it for tonight. Later.